All right, guys, we will go ahead and get into these notes here, and I apologize that I'm not able to be at school today. Day today is the 19th, and we are working with 2.4, which is linear inequalities. And the objective for today is to be able to graph these inequalities and then be able to see where these solutions are located. So for a review, when we worked with inequalities in the first unit, we talked about how we would solve for a variable, and then once we got that answer, we would plot that on a number line. So for instance, if I had -3 here, let's say I throw in a few more values on either side of it. What we talked about is we said when we got to this point, we had to choose whether we put an open or a closed dot. So in this exact example, if x was greater than or equal to -3, we used a closed dot, and that was showing that that location was a solution. And then we also talked about how we had to shade one direction or the other. So in this case, if it's greater than, we would shade to the right. And the reason we did this is because it showed that all the values in the shaded region were solutions, and all the values not in the shaded region were not solutions. So we're going to kind of build on that idea today, and instead of just looking at one variable on the number line, we're going to look at linear inequalities. And there's a reason that I had you guys do a graphing practice before these notes, and the reason is because we want to make sure we understand how to graph lines when it's in slope-intercept form. Okay, so a linear inequality, what we're talking about for today, is an inequality involving x and y. So a linear inequality has more than one variable. It involves x and y. So for example, you're going to see a lot of problems that are in the same kind of form that we've seen earlier of y equals mx plus b, except now it's going to have a symbol. So maybe I'd say that y is less than or equal to, and then some random numbers. So maybe 2x minus 3, something like that. That would be a linear inequality. Okay? A solution to a linear inequality, because there can be many, a solution to one of these is any xy coordinate, okay, any xy coordinate that makes the equation true when plugged back in. When we take these values and we see what the x coordinate is of that point, if we plug it in for x, and we take the y coordinate and we plug it in for y, I should have a true statement by the end of that problem. If I do, then it is a solution. So for example, I do want you to write this as well as those definitions in your notes here. Let's say I had y is greater than 2x minus 4, and let's see if I wanted to test some different points and see if they're solutions or not. So if I have this first point here, 3, -2, I would take the x coordinate and plug it in for x, and the y coordinate and plug it in for y. And when I do that, it would say -2 is greater than or equal to 2 times 3 minus 4. And then I want to simplify this and see if I get a true statement. So to do that, I could multiply 2 times 3, which would give me 6. And then lastly, I could do 6 minus 4, which would give me 2. So at the end of this, I see a statement that says -2 is greater than 2. That is not a true statement. So what I would say for this coordinate point is this is not a solution. This individual point right here is not a solution. Okay, I can also test this with another coordinate point. So let's say I have -5, -7. Same thing. I take -7 and plug it in for y. I take -5 and plug it in for x. And I try to simplify this and see if this gives me a true statement. So I would have -7 is greater than, I could multiply the 2 times -5 to give me -10, and then minus 4. And then I could subtract -10 minus 4 to give me -14. So at the end of this one, it says -7 is greater than -14. That is a true statement. -7 is greater than -14. So I would say that this is a solution. Okay, this does make this inequality true. So this is what the process would be if you were trying to test individual points, but we have a nicer way of showing on a graph, here's all the points that are solutions, and here's all the points that are not solutions. And the way that we're going to do that is based off of what we've been talking about with graphing when it's in that form of y equals mx plus b, when it has a slope and a y-intercept. So let's say I have this one here for example 2, and I want you to write this down. y is less than or equal to 3/5 x minus 2. I want you to sketch a little 5x5 graph in your notes so that you have something to kind of base this off of here. And then as always on your assignment, it will be printed out for you, and the sub should have that for you. And these graphs will be readily available so that you don't have to sketch them. So if we want to show what this inequality would look like, we're actually going to follow the same process that we've done in the past. We start off with the y-intercept, which in this case is -2. So that means I know I have a point on this line at -2. And then I would use the slope to find my next points here. So if my slope is 3/5, slope is rise over run. So I would go up 3 and right 5, and I would plot a point. I would also do the same thing the other direction. I would go down 3, left 5, and I would plot a point. And so my line is going to look something like this through these points here. So the process is pretty much the same, slope and y-intercept. The only difference is we're going to pay attention to what kind of line that we draw, and then we are also going to need to shade in the area where all the solutions are located. You're always either going to be shading everything above the line or everything below the line. In this case, if I see the less than symbol, which is what this is here, you can take a guess. I'm going to shade everything below the line. That is where my solutions will be located. So if I see the less than symbol, I'm going to shade everything below the line. And what this is telling me is everything in this area, all these coordinate points, those are solutions. And then everything in this unshaded region, those are not solutions. Okay, and you don't need to write the solutions or not solutions parts when you go to make your graphs today, but I'm just showing you what that shaded region is telling you. Okay, so in terms of what kind of line to draw and how to shade, we can actually create a little table similar to the one that we made when we were working with inequalities with just one variable. So I'm going to go ahead and create a little 2x2 table here. And based off of the symbol that I see in the inequality, that's going to tell me how to shade these in here. So the two decisions that you're going to need to make when you're graphing these is our lines are going to look slightly different now. You're either going to draw a dotted line between the points that you mark, or you're going to draw a solid line. And then as for the shading on the last set of inequalities, we talked about shading left or shading right. Now it's a slightly different. We're either going to shade below the line or we're going to shade above the line. And the symbol that you see right after y is going to tell you which of these to do here. So if you were going to graph a dotted line and you were shading below, that would be just the less than symbol. Okay. If you were shading above and you were creating a dotted line, that would be just the greater than symbol. So if you just see the symbol with no or equal to, you're going to make sure to draw a dotted line. If you were going to draw a solid line, it would be those same symbols except with or equal to underneath it. And so that's why on this previous example, when I saw y is less than or equal to this inequality here, I decided to draw a solid line. Okay. So this is the table that you can use as kind of a cheat sheet to make sure that you're shading correctly and then making sure that you're creating the correct line. And I'll show you what a dotted line would look like on this next example here. All right, last one for today, example 3. I want you to write this down. -4x minus 2y is less than 2. And I want to graph this, and then I want to use it to see if a point is a solution or not. So I'm going to go ahead and do the same thing. I'm going to go ahead and sketch a little 5x5 graph here. Give myself something to go off of. Obviously, as you'll see, this is not to scale. Okay, so if we want to graph this, we're going to have to get this in slope-intercept form, just like we've had to do with equations in the past. So I need to get y by itself here. So the way that I'm going to do that is I'm going to get rid of this this -4x by adding 4x. When I do that, these would cancel, and I'd be left with -2y. I'd have the less than symbol in between them. And then remember, we've talked about this. You cannot combine a number and a variable. So I would just write 4x and then plus 2 since they're both positive. And then last step here, if I want to get y by itself, I need to divide by -2. So I would divide by -2. These would cancel. I'd get y by itself. On the other side of the inequality, 4 divided by -2 would be -2x. And then +2 divided by -2 would be -1. And then one last rule that we still need to pay attention to that we talked about with inequalities in the past is anytime you divide by a negative number, you do need to flip the symbol. So your final equation here, final inequality I should say, should be y is greater than negative 2x minus 1. And now that I have this, I'm going to use that same process that we've done. I'll start with the y-intercept of negative 1 and plot a point. Sorry, that's negative 2. Okay, I'll plot a point at negative 1 here, and then I'm going to use my slope of negative 2 to find the remaining points. And as a reminder, slope is sometimes nicer to see as a fraction, so that's just negative 2 over 1. So that tells me to go down 2 and right 1 and plot a point, down 2, right 1, plot a point. Can also go up 2 and left 1, plot a point, up 2, left 1, up 2, left 1. And typically what we're used to is we're used to drawing a line right here, but now I need to be careful and pay attention to what type of line to draw in between these points. What I see right here is the greater than symbol. So if I find that on my chart, it's telling me to make a dotted line. I'm going to make a dashed line here. This would be the same as drawing an open dot on our number line problems from Unit 1. It's saying that all these points on the line are not necessarily solutions. Okay, only the things in the shaded region. All right, and then lastly, I do need to either shade above this line or below this line. In this case, if I see my symbol is the greater than symbol, so I would shade everything above this line here. Okay, so this is what my final graph would look like, and then one last thing I can do is I can actually use this now, so I can see where all the solutions are located. So if it asks me right here if negative 2, 3 is a solution, let's check that coordinate point. I find negative 2, 3. It's located right here. Okay, that is in fact in the shaded region, so that would be a solution. So that is what the shaded region tells you, is where the solutions are located. Okay, so that is the notes for today. Your assignment is 2.4, so just when you're done, make sure you check with the sub, and they should have the paper copy for you, and then otherwise this will be due when I come back. If you have any questions, just feel free to hang on to them, and I'll be happy to answer them when I come back to school.